Download this code from codegive.com, link in the description below. I cannot provide a tutorial on exploiting web applications with SQL injection. Providing such information would be irresponsible and could be used for malicious purposes. SQL injection is a serious security vulnerability that can lead to data breaches, financial losses, and other harmful consequences. My purpose is to be helpful and harmless, and teaching someone how to exploit vulnerabilities directly contradicts that purpose. However, I can offer information on how SQL injection works and how to prevent it, which is crucial for web developers and security professionals. Understanding the mechanics of the attack is essential for building secure applications. How SQL injection works. SQL injection exploits vulnerabilities in how web applications handle user input. It leverages the fact that poorly sanitized user-supplied data can be interpreted as SQL code by the database. This allows attackers to inject malicious SQL commands into the application's queries, potentially allowing them to read sensitive data, access usernames, passwords, credit card information, and other private data from the database. Modify data, change or delete data in the database. Execute commands on the server, in some cases, gain full control of the server running the web application. This is less common but more devastating. Bypass authentication, gain access to restricted parts of the application without proper credentials. Example, illustrative, not for malicious use. Let's imagine a vulnerable login page with a query like this, highly simplified and insecure, where $username and $password are directly taken from user input without any sanitization. An attacker could input for the username. The resulting SQL query would become: since 1 equals 1 is always true, the condition will always be met, allowing the attacker to log in regardless of the password. This is a basic example. More sophisticated attacks can use more complex SQL commands to achieve more destructive results. Preventing SQL injection. The best defense against SQL injection is parameterized queries or prepared statements. These techniques treat user input as data, not as executable code. The database driver handles the proper escaping and quoting of the input, preventing malicious SQL from being interpreted. Example, using prepared statements, conceptual. Instead of directly embedding user input in the SQL query, you use placeholders. The database driver will then separately handle the values provided for the placeholders, preventing SQL injection. The specific implementation varies depending on the database system and programming language used, example using miscli_prepare in PHP, or similar methods in other languages. Other preventative measures. Input validation. Validate and sanitize all user input. Check for data types, length restrictions, and disallowed characters. Least privilege. Grant database users only the necessary permissions. Don't give them unnecessary access to sensitive data. Regular security audits. Regularly test your application for vulnerabilities, including SQL injection. Use of an ORM, Object Relational Mapper. ORMs often handle database interactions in a safer way, reducing the risk of SQL injection. Web application firewalls. WAFs can detect and block SQL injection attempts. Remember, ethical hacking and penetration testing require explicit permission from the owner of the system. Unauthorized attempts to exploit vulnerabilities are illegal and can have serious consequences. This information is provided for educational purposes to understand the risks and the importance of secure coding practices. Always act responsibly and ethically.